Croczilla here. I'm here to talk to you about APES, Chapter 17. You've seen me in Croczilla, Croczilla 2, and Son of Croczilla. Okay, enough of the fun stuff. Let's get down to business here, okay? So for us, we're looking at environmental hazards and human health. We're looking at people face hazards from biological, chemical, physical, cultural factors, and from the lifestyle choices that they make. So your homework would be dealing with mercury's toxic effects. We did talk about that before, but we're moving on. So we talk about risk. The risk is the possibility of us being harmed. Risk assessment is the scientific method of evaluating how dangerous something is. We look at hazard identification, the probability of risk, and the consequences of risk. Okay? So that's pretty straightforward there for that. When we look at risk management, it's deciding whether or how to reduce a risk and at what cost. So we do a comparative risk analysis. How much should it be reduced? What kind of a risk reduction strategy should we come up with? What would that look like? We also talked about major health hazards. And here's the thing. Most people are not good in assessing risks. This is not something that we naturally do. If you think about it, when you were a little kid, you were riding a bike or you were riding a skateboard. You know, you took risks because you didn't know any better, and sometimes you fell, you crashed, you got hurt. You know, that's part of us not good at assessing risks. Okay? All right. But we talked about hazard types. Cultural hazards like poor diet, poverty, driving, drinking, criminal assault are examples of cultural hazards. Physical hazards, ionizing radiation, a hurricane, tornado, earthquake, tsunami. Chemical hazards, harmful chemicals in the air, food, water, and soil. Did I mention salt? Biological hazards include things like pathogens, bacteria, virus, parasites, pollen, allergens, bee stings, and snake bites. So all those are the risks and hazards that we face. We talk about, in looking at 17.2, in terms of death rates, the most serious infectious diseases are flu, AIDS, diarrheal disease, malaria, tuberculosis. Most of these deaths occur in developing countries, sad to say. Kind of biological hazards that we're facing, disease. There's infectious and non-transmissible. Non-transmissible are caused by non-LO. LO means living organism and does not spread, like diabetes, cardiovascular issues. Those are examples of non-transmissible diseases. You cannot give somebody diabetes. You cannot give somebody heart issues. You can't. Now, infectious disease, on the other hand, that's when pathogens or parasites invade the body and multiplies in its cells and tissue. It should be multiply in cells and tissues. Now, they do it in their own way. Pathogens would include things like bacteria, viruses, protozoa. Think tiny little creatures, okay? Like Giardia, which can give you massive amounts of diarrhea. Amoeba, okay, that's another type of protozoa. All right, so that's what you get with infectious diseases. Now, transmissible diseases are infectious diseases that are transmitted from one person to another. Excuse me. Faking! But examples like flu, HIV, measles, tuberculosis, those are all transmissible diseases. Now, but how is it, you know, how do they get transmitted? It could be through body fluids, it could be through the water, it could be through the air, okay? There's a number of ways that happens. Contact, physical contact, okay? It's one of the reasons why the school places those hand sanitizers at different places for people to, you know, rub their hands, because germs are everywhere. So how does the infectious disease work? Bacterial, they multiply in the body. Viral, the virus spreads when it takes over a host cell and makes that cell reproduce new viruses. It's still arguable if a virus is considered a living thing or not. It doesn't need food, it just replicates, that's it. Take over a host cell and it can either immediately get the cell to replicate new copies of the virus, or take over the cell and sit there and do nothing for years and years, and then all of a sudden, boom, it starts to replicate and you end up getting all kinds of viruses and bad things out there. We talked about epidemic, large-scale outbreak of an infectious disease. Okay? Pandemic is when it's on a global scale, like HIV, AIDS. Okay? HIV is the virus that ultimately causes AIDS. AIDS is the full-blown consequences when your immune system cannot defend itself from something as simple as a cold. That is the sad part with that. Okay? So the types of biological hazards that we face, we've talked about trends in TB is short for tuberculosis. Okay? If you notice, that is starting here in 1992 compared to 2017, that has been going down. But if you kind of notice here, it's kind of slowed down. We have not been able to eradicate it yet. Okay? Another problem that we have, and that you guys got to read on your own, is the problem of antibiotic resistance. Okay? The problem is that with antibiotic resistance, it used to be we could treat bacterial infections with antibiotics and it was easily taken care of. But doctors have also in the past given lots of antibiotics very freely, and what's happened is that there's always those few types of bacteria that have a natural resistance to antibiotics. They're the ones that keep multiplying, and that makes it a lot harder. Things that can be, how can the resistance be prevented? Responsible use of antibiotics, communication on health issues, hand and kitchen hygiene, washing hands, things like that, health system performance, clean food and water, vaccination, all those things can help. Again, you'd have to read about the global study about global HIV and virus. Effectively, what HIV does, it takes out the helper T cells that allow your body to be able to fight. Okay? I got more into it when I was in bio. We talked about malaria. This is another case where you're going to read this on your own about how malaria works. It is spread by the mosquito. Okay? And once a person has it, they have it for life. They do get outbreaks. And it is easily treatable, but once you have it, you have it. That's the end of it, okay? So viruses, the thing is, it does leave large numbers of people dead. I'm trying to see our timing here, okay? Why? Well, you can't use antibiotics to fight viruses. They're unaffected by it. Bacteria, yes. Viruses, no. They're easily transmitted by body fluids or airborne transmission. Now, virus types for us, there is influenza, which is also known as the flu virus. That is the #1 killer. If you're looking at the types of viruses, HIV is the #2 killer as well. That's just brutal how it works. Okay? There is also the hepatitis B virus. Hepatitis B is a disease caused by the virus that's in your liver. And it affects the liver and it kills about 1 million people per year. There is the West Nile virus, which causes encephalitis. This is an inflammation of the membrane in between your brain and the skull. It's not a good thing. Meningitis. Okay, encephalitis, I'm sorry, that is causing a deformity. Meningitis is the one where it is the membrane in between your skull and your brain. Caused by the West Nile virus. We do have that here in Southern California. We also have SARS. severe acute respiratory syndrome. It first appeared in China in about 2002 that we're seeing. Okay? So those are some of the biological hazards that we're facing. Okay? Moving on, 17.3. There is a growing concern about chemicals that can cause birth defects and cancers and disrupt the human immune, nervous, and endocrine systems. Endocrine, think hormone. Okay? Think of the hormone. What are the chemical hazards that we have? There is a difference between toxic chemical and hazardous chemical. Toxic causes temporary or permanent harm to living organisms. That's what LO means, living organism. In other words, a grasshopper, a human, a freshman, a dog, a cat, okay, presidents, dictators, Democrats, Republicans, alligators, sophomores, salty seniors, all those are considered to be living organisms. Hazardous chemical can harm living organisms due to flammability, explosiveness, irritation, and allergic reactions. And when we say irritation, this is not irritation because somebody says things you don't like. It's irritation in that it comes in contact with your skin or maybe your nasal membranes or your lungs, and it causes pain and discomfort. That's what we mean by irritation, okay? Not because the salt that some people pour out. That's not an irritation of that nature. That's not a hazardous chemical. That's just a social irritation. Okay. Types of toxic agents. We've got to get into this. Mutagens and teratogens. Mutagens causes mutations or changes in DNA. Like example, nitrous acid, HNO2. Now, what do we mean by causing mutations or changes in DNA? This is not forget lab safety, bring on the powers, baby. No, it doesn't work that way. That's where science fact and science fiction collide, and you end up becoming, you know, the Hulk after all the gamma radiation that you end up getting and all that. Croxilla would be another example of it was exposed to mutagens that cause mutations. Teratogens causes harm or defects to a fetus or an embryo. Fetal alcohol syndrome is an example. The baby was born and mom was drinking alcohol during the pregnancy and she was drinking a lot. It does have a physical effect on the baby. It also has a mental effect on the baby. It's really sad. This is, you know, it's really truly sad. Okay, let's move on. Now there are other toxic agents like carcinogens. Carcinogens are cancer causing, or they're known to cause cancer, okay? So things like arsenic, benzene, formaldehyde. We used to have that old school biology dissection specimens. Nickel, the metal nickel, not the nickel coin. X-rays, vinyl chloride, PCBs, polychlorinated biphenyl. Those are also, they also have carcinogens in there, okay? And sometimes you may go to a store and it'll post up a sign that says Prop 65 saying, hey, the state of California wants you to know some of these things contain known carcinogens. They have been known to cause cancer. Well, practically everything you get can cause cancer. So, I mean, you either live or not. Okay? Effects on the human body. So when we look at chemical hazards and effects on the human body, we have to look at the immune system of the human body. Specialized tissues and cells that protect the body against disease and harmful substances. Okay? Things like neurotoxins and hemotoxins. They're both poisons, they're nasty, but the neuro affects the nervous system. Hemo affects the blood. So for example, as I got to look here at our timing, all right, when you are looking at rattlesnakes in the state of California in the desert, most of the rattlesnakes that you will see are like western diamondback rattlesnake. They will inject hemotoxins into somebody. If somebody gets bit by a rattlesnake, typically it's a hemotoxin. If it's the Mojave Desert rattlesnake, which is a little bit greenish, it injects neurotoxins in there. What would be the difference if you were bitten? You have more time to get somebody to the hospital if they're bit by if it's a hemotoxin in them. If they have been bitten by the Mojave Desert rattlesnake that has a neurotoxin, they only have a few hours to get there. Even if you try to slow it down by putting, a tourniquet on there, it's affecting the nervous system, which affects your brain, your spinal cord, your ability for your heart to keep beating, okay? All those things come into play. So neurotoxins are definitely much more dangerous compared to the hemotoxins. Effects on the human body. Let's talk about the endocrine system, the hormone system. Think for the ladies, you have estrogen, you have progesterone. Those are two examples of hormones in the female human body system. If you look at the male human body system, you have what is called testosterone, okay? I can actually speak more about testosterone than obviously estrogen and progesterone, okay? Again, releases hormones through tiny glands into the bloodstream of humans and animals. Hormones connect with the receptor on the membrane of the target cell. Now, those receptors tend to be very specific, okay? And this is just giving you an idea. This is your target cell, and here's the receptor. Here's your signal for the hormone, okay? Because really a hormone is a protein. It really is. And it connects, and voila, good things happen. Let's move on here. Hormonally active agents. This is where life gets to be interesting, and I'm paying attention to my timing here because I got to wrap up. So, hormonally active agents, there are chemicals that mimic hormones. Well, what do we mean by mimicking hormones? Well, I can take this,
and I'm Croczilla, or at least I'm mimicking Croczilla.
It's an imitation, okay? So hormonally active agents, chemicals that mimic hormones. Now there are thyroid blockers, and what happens is it'll cause weight, brain, growth, and behavioral disorders. That's a problem that we can have from a chemical hazard. Hormone blockers prevent natural hormones from attaching to the receptors. Gender benders, estrogen mimics and hormones blockers. Okay, this affects on sexual development and reproduction on animals. As far as humans, I don't know, and as far as, the number of gender identification labels out there, it has nothing to do with the gender benders. We're seeing this notably in fish. We're seeing that. Effects on sexual development and reproduction on animals. The problem is, if that's affecting it, then their ability to keep the species going, that's a problem. Okay. Last thing here, this is dealing with BPA, bisphenol A. It's an estrogen mimic. And this is one of the problems now where a lot of the bottles, plastic bottles, have BPA in it compared to plastic bottles that are now BPA free. So this is some of the hazards that we deal with, okay? And, well, guys, that's going to be it because our next episode is 17.4 as we're boldly moving through here. And we're over halfway through the chapter, okay? All right. So this is it, guys. Take care and good luck.